Lab 2, Magnetic Field of a Bar Magnet. Introduction. This experiment involved a bar magnet and a magnetometer in our phone to measure a magnetic field. We observed the V field on axis and off axis from the bar magnet that acted as a dipole. GlowScript was used to model points on and off axis from the dipole. The purpose of this experiment was to compare the model calculated B field to the observed B fields and determine the dipole moment of the bar magnet. This experiment used the concepts of magnetic fields of dipoles in the parallel and off-axis directions. This concept was key to determine the magnetic field of a dipole on the magnetometer and estimate the dipole moment. The main results found that the magnitude of the dipole moment, or mu, was about 0.0358 am squared, and it was also found that the modeled B fields were much greater than what we actually observed. Model overview. Figure 1 shows 4 perpendicular points represented by the blue arrows, and 2 parallel points represented by orange arrows. There's also a purple arrow that represents the point of 45 degrees away from the dipole. Experiment, theory, and model assumptions. The main equations used in this experiment were the magnitude of magnetic fields from a dipole on axis and the magnetic field of on an observational point off axis at an angle. The formula on the far right was primarily used in the model. Assumptions in the experiment were that the magnetometer was aligned completely with the magnetic north so that the exponent of B field would be 0. In the model, we assumed that z-axis was 0. Sources of error may have come from nearby electronics exhibiting their own magnetic fields and the magnetometer not being completely aligned with the North Pole. Experiment methods. In this experiment, we located the magnetometer in the phone and aligned it with the North Pole. We then measured the x component of the B field certain distances on axis away from the phone. We then calculated mu from these measurements. We calculated the B field from an observation point off axis from the dipole. We then used GlowScript to model the B field on points on and off axis to compare our observed measurements. The initial position of the dipole was at the origin. The distance we used for the on-axis and the perpendicular axis was 0.059 meters, and the distance of the points 45 degrees from the dipole was 0.179605 meters. We used the calculated mu in the model as well. The system was the magnetometer and the surroundings were the bar magnet and the Earth. Experiment code. Here is the code for the model. Here we can see the function used to calculate the B field. We also have arrows representing the B field at certain points around the dipole, such as on axis and perpendicular. The final snippet of code represents the observational point that is at an angle 45 degrees away from the dipole. We found that the x component of B field is nearly 0, if not completely, when the magnet is far away. However, as the distance between the magnet and the magnetometer lessens, the B field starts to increase. We found the magnitude of the dipole moment to be 0.0358 am squared, and the B field of the off-axis point to be 1.43376 times 10 to the negative 4th teslas. The model results are shown in the following vectors, with the first 2 vectors representing the on-axis, the next 4 points representing perpendicular axis, and the final vector representing the 45-degree vector. Though they're in vector form, when calculating magnitudes, they are much greater than what we actually observed. What if? If the experiment was done at any given angle and not necessarily in line with the North Pole, we would have to account for the Earth's magnetic field in our calculations, as we cannot calculate the field from the magnet and Earth separately. This means the observed B field would incorporate some from the Earth, so it would be greater than solely if it was just from the magnet. What if? If 2 magnets are put end to end and used instead of just one, they will act as a much larger dipole. This in turn will have a greater dipole moment and thus greater magnetic field on the object. Conclusions. Modeled B fields were calculated to be much greater than B fields calculated from observed data. Model seems to be less accurate at closer distance, but better at predicting B fields at larger distances.